All right, so let's review again, and hopefully by the time we're done, you guys are good. Remember area. Don't forget it's the number of square units that cover a surface, and so it's always square units, square inches, square feet, square miles, etc. Start off with the area of a parallelogram, base times height. Remember the height is always the perpendicular distance between the parallel bases. From area of a parallelogram, we went to area of a rectangle. Area of a rectangle can be base times height. What's the other formula? Somebody raise your hand. Another formula. Adriana? Madison? Wow. Length times width would also work then for a rectangle. And because a rectangle is at right angles, one of the sides is always the height and the other is the base. And then area of a square, base times height. What's the other formula for area of a square, Gabe? Side squared. And again, because the square are at right angles, then one of the sides are always the length and the other is always the base. All right, don't forget problems like the two on the bottom. What happens when you get an irregular shape? Now at this point, we've had semicircles, circles, triangles. There can be other shapes associated. Break it up into the shapes you can find the area of. In this one, we broke it up into rectangles. In this one, we did area of a parallelogram minus the area of the square hole, right? Minus the area of the hole, and away we went with that. All right, then we went to area of a triangle. Don't forget the half. Area of a triangle, 1/2 base times height. Remember, any of the three sides of the triangle can be the base, right? But you're going to use the side that comes with its height. If this is the height, then that's the base we want to use, and that's the number we need. If this is the height, then that's the base, the side it's perpendicular to. And if this is the height, then that's the base, the side it's perpendicular to. Some of you guys that do the worst in the class, you're the ones not paying attention right now, and that is the reason why you do poorly in the class. You don't pay attention, you lack focus, and therefore you don't remember things. Okay, so it's important that you always associate the correct base that will go along with the height that's given to you. And so area of a triangle, we went through problems like that. Again, you can have then area of a trapezoid, 1/2. Parentheses, you got to do that in the quantity, base 1 plus base 2. And in reality, what ends up happening with a trapezoid, it's just like a parallelogram. Whoa, let's see if I can get this to work. If I take this and spin it, oh, I gotta rotate, no, I gotta, all right, can't do it in this program. If I was in Corel, I could do it because it would make it flip up. But anyhow, you've got to add the two bases up, take 1/2 of it, and then times the height. How do you know what the base is? So how do you know what the base is? It's always the perpendicular distance between the parallel sides, right? This one is an odd one here on the bottom right. That's an odd-looking trapezoid, but it is possible to have that. And again, the bases are the two parallel sides, right? The height, the perpendicular distance between them. So just be careful, and that shape can be spun in any kind of an angle. All right, so we use that formula. Let me go back. Let's see what's on the bottom here. All right, shape like that. Again, what did we do? Area of a trapezoid minus the area of a triangle, and that allowed us to figure the shaded area of that bottom shape. Area of a circle, pi r squared. Pretty easy. All you need to do is know the radius. Maybe we won't give you the radius. Maybe we'll give you the diameter. Okay, not a problem, right? Radius is 1/2 the diameter. Maybe we'll give you the circumference. Well, you can use the circumference formula to find the radius. Circles relate that way. Just be careful. You're squaring the radius. Follow the order of operations, and make sure you end up with units squared. We are using 3.14 for pi. Last thing we did was an odd shape like that, which ended up being a triangle plus 1/2 of a circle. And again, there could have been holes in it. Maybe I'll give you, let's see, can give you eyes. If I give you a mouth, you won't be able to figure out. Can I do a triangular mouth? Would that work? Oh, that would work. Could you figure out the area of the shaded of that? You could. It would be area of the large circle minus area of the circle minus area of the circle minus area of the triangle, right? And that would leave you the shaded area. That's possible. You can do it. And so you just never know. Jack. Pi r squared is not the circumference. Circumference is pi d or 2 pi r. For the area, pi r squared. No, 2r is the diameter. For example, if the radius is 4, the diameter is 8, 2 times 4. But r squared is 16, 4 times 4. All right, so circles, and we did those, should be able to handle circles. That brought us to the quiz, and then that brings us now to, so before I do 13.6, let me just remind you what 13.4 and 13.5 said. You don't need to draw this, just look. We started off with similar figures. Let's suppose those are similar triangles. For similar triangles or any similar figure, we know the angles are, class, congruent, and the sides are proportional. Not only that, take a, here I'll use green here, take an out, I'll use green here, take a height, which is also an altitude. The heights are also proportional and in the same proportion as the sides. But what about the area? What was the area? Anybody remember the relationship with the area of the similar figures? The areas of the triangles are proportional to the sides squared. Right? So that's a little bit different. The area is proportional to the sides squared. And it makes sense. Area is in square units. It should be an easy thing to help you remember. Hey, I got to square my sides if I'm going to use a proportion. All right, so that was the first part. And then the second part was surface area. And now I'm in trouble if I try to draw something. Whoa. That went south very quickly. That's what I want. Like that, like that, like that. Like that. Right? Remember, the surface area, you have to figure out the area of every surface. How many surfaces does that figure have? How many surfaces, Raquel? Nope. Nick? There are 6 surfaces. There's a top and a bottom and then 4 sides, right? So you got a total of 6 surfaces, and you'd have to figure out the area of all 6 surfaces. What if that were a cube? A cube is made up of all squares. So it would be easy to figure out the surface area of a cube, figure out the area of one of the sides, and then do what to it? Jordan? Nope. Cube. Josh? Multiply it by 6 because all 6 sides are exactly the same size. A cube. All right, a cube, by nature, all sides are exactly the same size. Okay, so that was those 2 lessons. All right, go away, go away. I should have just erased it. Probably. It's great. Go. Go, 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 go. Hello. Wow, really went far. All right, there we go. Okay, so now we got to deal with surface area of other solids. So we dealt with a few, and now we need to deal with a few more. So let's see. Let me pull in here a cylinder. Okay, so here it is, a cylinder, right? And I don't know, a Coke, can of Coke. It's pretty close to a cylinder. You know, the cans aren't nice and round anymore, but that's a cylinder. So how in the world will we figure out the surface area of a shape like this? First off, What kind of shape is the top and the bottom? Somebody raise their hand. What kind of shape is the top and the bottom of this thing? Ashton? They're circles. They're circles. So what about the rest is called the lateral surface? Again, you don't need to write anything. You're just thinking. This part is called the lateral surface. What kind of shape would that be if we opened it up? What kind of shape would it be if we opened it up? Sam? It would be a rectangle. So if you were to open this thing up, it would basically be, let's see, let me get rid of my wording here. If only I could draw straight. So it would be something like this. That would be the lateral surface, right? We would have a circle on the top and a circle on the bottom, right? Would you agree? And that's what we'd have to figure out the area of. Okay, so let me throw in some values. Let's suppose this is a 4 inches. And let's suppose this is 6 inches. Would we have enough numbers to be able to figure out the surface area of our cylinder? Let me go ahead and move our sphere out of the way. Okay, so if we were to do a formula, all right, so the surface area, surface of a cylinder, would be, how many circles do you have? So it would be 2 times the area of a circle, right? Because the top and bottom are the same size, plus area of the lateral surface. Okay. Somebody raise your hand, tell me the formula to use for the area of a circle. Matter of fact, let me call on someone. So everybody thinking, formula for area of a circle. Natalie, what do you think, area of a circle? Not 2 pi r. Area of a circle. Antonio, area of a circle. Pi r squared. All right, so Sicilian. Pi r squared. And what kind of shape is our lateral surface? So I need a formula for the area of the lateral surface. Adam, area of lateral surface. Area of the lateral. What kind of shape is the lateral surface? Okay, what's the formula for area of a rectangle? Base times height. I agree. Okay, so that's what we need to do to figure out the surface area of our cylinder. Okay, let's start putting in numbers. Wyatt, what are we going to put in for pi? 3.14. All right, good to go. What are we going to put in for the radius? Hector, what are you going to put in for the radius? Speak up for me. You're probably right. Speak up. I just couldn't hear you. 4. Yeah, it's 4. And it's inches. I always keep my units. John, can you close that door for us? And don't forget that's squared. Okay, plus. Can somebody give me either the base or the height of our lateral surface? Need the base or the height of our lateral surface. And tell me which one you're giving me. All right, Jack? 6. Okay, that's a 6. Yeah, you're thinking it's a 16. That's the H letter, and then 6 next to it. Okay, so our height is 6 inches. Can anybody tell me what the base is? Really? That many of you? Awesome. The base. Abby? 8 inches? Not quite. No. Not quite. Not the case. We need this value right here. And it is not 8. Kaylin? 16. How many agree with Kaylin? 16. Okay, how many disagree? Anybody want to debate the 16 cos? Why it's 16? Stan? No. All right. Anybody else want to debate the 16 cos? Connor? All right. 0 for 2 on the 16 cos. Jack? And that's 16. Agreed? Did that convert anybody? Did it unconvert anybody? 16? You like 16? Everybody likes 16. Jack, say what you said again. Okay, it's as long as the circle is round. All right, so let me see if I can find the right prop here that I need. I'm really not seeing the best kind of prop here. All right, just going to have to use a piece of paper. It's not my preference. I would have preferred cardstock. Okay, a cylinder. Everybody see the circle at the base? Everybody sees it, right? All right, would you agree the radius would be from the center to one of the sides, right? That amount of distance, yes? Okay, and the diameter, those of you that said 8, would be all the way across, right? So when I open it up, it definitely wasn't 4, was it? And it definitely wasn't 8, was it? So again, do you see, right? You see the circle? See me open it up? What is the base? Don't say anything out loud. I'll show it to you again. Here's the base, right? It's a circle, but we're going to figure out what is the distance of the lateral surface's base. So again, you're looking at it. When it opens up, what's this distance from here to here? Who said that? Who just spoke? Somebody from over here. Now, if you're going to make me go through every student in class to figure out who just spoke, then I'll go through every student in class. Who just said something? Byron? Okay, come see me after class because I said don't say anything. Okay, because people need to think. All right, so you're looking at the circle, right? You're seeing this would have been the base. We got to figure out what is the distance when this thing opens up from here to here. How many think they've got it or you got an idea? Not enough. Come on, are you looking? Are you thinking? Are you thinking? Look, right here, right? We need this amount, right? See it again? Okay. You guys see it? Romper, stomper, romper room. I see Joey and Billy. All right, you guys are too young for romper room. All right, that was a crazy show for kids. All right, so you open it up, and you got it. Okay. On 3, if you think you know it, tell it to me on 3. 1, 2, 3. You know what? If you're telling me a number, you're probably wrong. Because if you're telling me a number, you're probably wrong unless you broke your calculator out. I'm going to show it to you one more time. You shouldn't be telling me a number. You should be telling me a concept. There is the base. I open up the lateral surface, and I need this distance. Give it to you one more time on 3. 1, 2, 3. And what I had hoped I would hear is, it is the circumference. Is it not the circumference of the circle? Look at the circle. Look at the base. See the base? Isn't that distance, the distance around the circle, the circumference? It is the circumference. All right, so now I need a formula for the circumference, and we all should know that that is 2 pi r. So what would go here is 2 times 3.14 and times our radius, not squared, we're not doing area, and 4 inches. All right, that would allow us then to figure out the surface area of our two circles and the surface area of our lateral surface. Every cylinder, the distance of the base is the circumference of that circle, because it just opens up. See it? It just opens up, and it's that distance across. That's the key to those. If you know that, you can figure everything else out based upon what we already know. So though it looked like you didn't have enough to figure out the surface area of that shape, you really did. You really did. All right, well, you can have some other shapes. Oh, that's a big cone. No ice cream in it, unfortunately. Okay, so there we have a cone, right? And we know what cones are. So again, you have, in this case, not two bases, but you'll have one base, right? And obviously the base is a, what kind of shape? Circle. And then the cone part, in your mind, would be the lateral surface. Cones are weird. If you were to open it up, you might think it would look like this. But try to make one. Take a piece of paper, cut a triangle out, cut out an isosceles triangle, and then fold it together and see if it makes a cone. It's not going to happen. It will not work. It is not the case. So it's not quite technically a triangle. The shape would look a little bit more like this. We have a little bit of a rounded edge. But in all intents purposes, this area, this line right here, because of that difference, this becomes the height. And this becomes the base. And you would do a half base times height. And for the circle, you would do pi r squared. Are there two bases on a cone? No, there's only one base. So you would only be doing one circle. That's the way cones are. That is the situation. But you're still using half base times height. Only the height is what's called the slant height. A little bit different, but that is the situation for a cone. Another shape is a pyramid. Keep getting the mark when I drag through. Okay, so a pyramid. What's going to happen with this thing? All right, I want everybody to get out a sheet of paper, or you can do it in your book. I'm going to want you to figure out the area of this thing, because some of you are falling asleep. You don't have the character to pay attention. You don't have to write notes, so you think it's time to just sleep, and that's not good. Okay, I know my numbers are not the greatest, so I'll interpret for you. That's 4 meters, 10 meters, 14 meters, 12 meters. Okay? So that left one is 14. And you hopefully you can see the difference between the 14 and the 12. The 12 goes up a side, or the 14 goes up a side to the peak, but the 12 goes from the middle of the base through the middle of the, by the way, what kind of shape is this? Pyramid, right? So from the center of the base up to the peak. All right, I want you to figure out the surface area. Surface area of a pyramid. Go ahead and figure it out. You've got to picture yourself splitting that thing open, and you got to figure out how to find the area. You should know enough to do it on your own without looking in the book. So figure it out. Do as much as you can, get as much as possible. Right, so our halves are gone. So now we've done the base, we've done the two left triangles, we got to finish the two right triangles, or the front and back triangles. So what is the base of the front triangle, Gabe? 10 meters. It is 10 meters. What is the height of the front triangle? You can't see much anymore, Abby. It was 12 meters. And so, and 10 times 12 is 120 meters squared. Oh, this is so unreasonable of any teacher to ask this of anybody. So let's see, we've got 40 and 56, that's 96, and 120. So what is that, 216 meters squared? Is that right? 90, yeah, 216. Anybody get it right? A few of you, awesome. Hopefully everybody should have this, right? That part done. That's the easiest. And I would have hoped you had at least a triangle or two going, and we'll find out when we look at your papers. 216 meters squared. Let me say something to you as a group. You guys have to get to the point where you start using your own brain. Look, you're never going to be nothing in math if all you can do is regurgitate something that's been given to you. That's all you can do. You're never going to do anything, not only math, in life. You got to use your brain. God's given you one. You all have one. You know, half of you guys, I hate to tell you, you just want to give up at like the drop of a hat. You just want to quit. You didn't even want to do it to start with. That was the problem. And that's like 5 or 6 or 8 or 10 of you in here. You didn't even want to start. Oh, it's too much to ask. How could any teacher ask of me a problem like that? How dare him? That's ridiculous. That's your problem to begin with. You were defeated before you ever started. And that was not a hard problem, doable. Hopefully you work your way towards it, and we'll see when I take a look at it. Okay, the last thing, I'm going to go way back. Find my sphere. There it is. The last thing is the surface area of a sphere. Now, this is completely a horse of a different color when you start to deal with a sphere, because when you open this thing up, you don't get a circle, right? I mean, you definitely don't get a circle when you open up a sphere. That's definitely not the case. So this one you need a formula, and you guys aren't required to learn this, but area of a sphere, and again we're talking surface area here. Well, there are a lot of circles in a sphere. Look, I can have a circle going around about here, right? That would be like longitude or latitude line. Latitude, right? Latitude. Is that red circle the circumference of the circle? No. I'm wondering, in geography, did you guys get a term for the circle that has the center of the sphere as its center point? For example, the equator. It's a blank circle. Anybody? Should have had it in geography somewhere. Anybody know the name? All right, if you think of Charlie Brown in Thanksgiving, maybe you'll get it. No, Charlie Brown in Halloween, I guess. All right. Charlie Brown special. What's Charlie Brown's Halloween special? I think it's the what pumpkin? The Great Pumpkin. All right, well, this isn't the Great Pumpkin. This is a great circle. It's a great circle. A great circle is any circle that has as its center point the center of the sphere. And there are lots of great circles. This one's already shown there, right? Can you see the shading there? And that great circle is like the equator. I mean, you could also have one like this, right? Coming around this way. And I mean, they could come around this way as long as the center of the sphere is the center point, and they're all equal. Any great circle has the same circumference. All right, well, what you've got to use is you've got to use the radius of the great circle. The either the equator or whatever. Again, any circumference that has as its center point the center of the sphere. And this one is simply 4 times then pi r squared. Not a hard formula and not hard to figure out. Let's see. Anybody know roughly the diameter of the Earth? Anybody know? Roughly the diameter of the Earth in miles. Nobody? Okay, let me help you out. About how many miles is it from New York to California? Anybody know that, roughly? Connor? Nope. Anybody know? Sam? It's about 3,000 miles, yes. Roughly from New York City to California. Is that about the whole diameter of the Earth? Is it about half? A little less than half? Yeah, it's a little less than half. Rough figure, the diameter now, not radius, diameter is about 8,000 miles. About 8,000 miles in diameter. So therefore, then the radius of the Earth is roughly 4,000 miles. It's a rough estimate, but it gets you close. So grab your calculators. I want you to tell me the rough surface area of the Earth. Okay, go ahead and punch that out. Remember, this is miles. So roughly, how much surface area is there on the Earth? What is the surface area of the Earth? I'm going to ask a few people, so calculate it, because I'm not going to do it. I got to trust you. Who's got it? John, what do you got? 200,960,000. Anybody else agree with that? 200,960,000? Okay. Anybody give it to him in scientific notation? No? Okay, because it wasn't that gigantic of a number. So that's 4,000 squared. Yeah, it looks about right. And this would be square miles. So about 200 million square miles of Earth. That's a lot of surface area. And by the way, that's not taking into account mountains and stuff like that. And again, that's a rough figure, but that's roughly about the amount of square miles on the surface of the Earth. Monday, when we do volume, we could figure out the volume of the New Jerusalem, which somebody said it recently, and they were like way off. Can't remember who it was. But they mentioned how many miles it was, and it's cubic miles, and it's like way more than that. So anyhow, we'll get to that on Monday. So though the formulas, it's not hard. It's just 4 times the area of a circle. All right, we'll quit there. Make sure you got your notes with you on Monday.